right, so this lecture we'll be talking about 2.1, not really a lecture, I just want to do a couple examples for you. And this is describing the graphs of functions. Describing graphs of functions. So you've already read this section, and I just want to do it. I want to highlight a couple of important things from this section, and then I want to do two examples. I'm just going to grab a couple functions from your book, a couple from the exercises, and show you how to do some of these. So chapter 2 is really out talking about applications of the derivative, and the big thing that we're going to focus on is how does the derivative help us find kind of characteristics of the graph of a function, okay? And then can we maybe solve problems using the derivative? Can I do different things? So the first thing that I want us to focus on in 2.1, we aren't actually doing any calculus in this section. We're just talking about how we describe a graph. So describing a graph. So this is on page 137. And I want you to be sure that you understand these are the things that we are going to be using to describing a graph. So the first one that we're going to talk about are intervals. Oh, I was a little crazy. Intervals of increasing and decreasing. Okay, where is my function getting bigger? Where is it getting smaller? That's important. Also relative maximum and minimums. Where do I have a mountain or a valley? So that's the first thing, and we are going to talk about how we're going to find this out we're going to use calculus to find these out, but for this section we're just looking at the graph. So that's one way we can describe a graph, is where is it getting bigger and smaller, where does it hit a relative max or min, the actual maximum and minimum value, if it exists, maximum. Not all functions have maximum and minimum values. How are these different than the relative? Sometimes you'll hear them called the absolute maximum or minimum. Okay, so these are guys that are just, well, so if I look at a function like this, we'll just pretend that is a crazy function. But this right here would be a relative max. This would be a relative min, because this function doesn't have an absolute max or min, because this guy goes down forever and that guy goes up forever. That's a beautiful graph right there. Number 3, this is concavity. Intervals where we are concave up or concave down, okay? So on this really horrible graph that I drew, as you read in the book, this is concave down right here. The yellow would be concave down, and then this pink would be concave up, right? So remember, this is saying that the yellow is saying that my slope of my tangent lines are getting smaller. That means I'm concave down, or they're decreasing. And then this pink part right here, this is what we say concave up, because the slopes of my tangent line are getting bigger. That's what it means by concave up. So we want to know intervals of concavity and inflection points. Again, for this section, we're just going to do this by looking at the graph, but we're going to figure out in the next couple sections how to do that using calculus. So those are inflection points. 4 is going to be intercepts, both x and y. Why do we care about that? Well, we might care where the function is 0 or where the function starts, right? And then 5 talks in your book about undefined points. Do I have a continuous function or do I not, right? Do I have a place where a point is not defined? That would be interesting for us on the graph. And then asymptotes. We're not going to spend a whole lot of time with asymptotes, but they're interesting things, both horizontal and vertical. So you need to make sure you can look at a graph and just look at the graph of a function and be able to describe these 6 things. And then later on, what we're going to see is how do we figure out how to describe these 3 things if we do not have the graph? What if we just have the function and that's it, and we don't know what it actually looks like? Okay, so let me grab one of these. So I'm just grabbing this. This is just from your homework. I think this is number 7, not your homework, one of the suggested problems on your homework. And so what I want to do here is I want the directions say describe. That's pretty general. So we'll just say describe the graph using the 6 things, right? So we'll just say using the 6 elements. All right, so if I look at this graph, let's first look at where are we increasing and decreasing. So number one, intervals of increasing and decreasing. So if we look at this graph, right, and as I go from left to right, look at what are happening to my function values. Oh, you cannot see that. What are happening to my function values? They're getting smaller, 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 smaller until there. Then they get bigger, and then they continue, wow, being smaller. Whoa, that is horrible. I'm gonna get rid of that. Sorry, you know what I mean though. So let's look at kind of what's happening here. So up until 0, okay, so from minus infinity to 0, and then from what, about 2 to infinity, what is happening? It looks like my graph is decreasing. Okay, so my graph is decreasing. I'm going to say from minus infinity to 0, not including 0, right? I'm neither increasing nor decreasing at that point. And then from 2 to infinity. You never include the endpoints on these. Okay, so I'm decreasing from minus infinity, from all the way over here. Remember, these are x values, decreasing, decreasing until 0. Then look at my function starts increasing. And then from 2 to infinity, I'm decreasing again. So where are we increasing then? Well, that just leaves from 0 to 2. Could we be constant? Of course we can be constant. That is another thing that we could say. So again, decreasing, you're listing x values just like you saw in the book, increasing. What was the other? That second I've already forgotten. Relative maximums and minimums. It looks like we have a relative min. Here's how I want you to write it. Of, what is my actual minimum value? It's your function value. It's 2, and where does it occur? This is how I want you to write it. It occurs at x equals 0, okay? So we have a relative minimum. What is the relative minimum here? It's 2, and it occurs at 0. We have a relative max of, what is our maximum? It occurs at 2, but what is the actual maximum value? It looks like it is 4. So I have a relative max of 4, and where does that occur? That occurs when x is 2, right? My maximum maybe profit is 4, and it occurs 2 days after the opening of the quarter, or something like that, okay? So this is what our number 1 has. Actual maximum and minimum values, we don't have any. Okay, so our actual maximums and minimums, they don't have an absolute max or min, because this function goes up forever and it goes down forever. So that's important to say. We don't have an absolute maximum or minimum. Now we have intervals where the function is concave up and concave down. So let's look at that, and let's pick a different color here and see if I can describe this for you. Let's use green. Okay, so concave up and concave down. This I'm going to trace here is where I'm concave up. Okay, you want to think of concave up as kind of a smiling face. That's how I think of it anyway. So where are we going to be concave up? It's kind of where, and if you look at the slopes of these tangent lines, I might get rid of that. That's hard to see. If you look at the slopes of the tangent lines here, look at if I drew these tangent lines, do you see the slopes of the tangent lines are decreasing, right? Or excuse me, increasing, concave up. They're negative, negative, negative. They get to 0. Then they start becoming more positive. And then as my tangent lines, do you notice how they're starting to become more negative again? So where am I going to be concave up? I'm going to be concave up all along here, here, here. They're getting bigger, bigger, bigger until about this point right here, and then they start getting smaller. So this is going to be concave up here. It looks like a bowl opening up. This is going to be concave down here. It's like a bowl turned down. I think of a smiley face and a frowny face. I don't know if that helps you at all, but whatever. So concave up. What is the interval where we are concave up? Again, from minus infinity, it looks like until about 1. And then where are we concave down? We are concave down from 1 to infinity. Okay, so that's our concavity. We're going to figure out later how to actually do that, how to find those intervals without having the graph. So concave up minus infinity to 1, concave down 1 to infinity, and that means we have an inflection point. Remember, an inflection point is where does my graph change concavity? The inflection point, notice it says point, please. What does a point mean? It's an ordered pair, and that point would be this guy right here, and I hope you can see it, but it looks like it's at 1, 3. Okay, so my inflection point, a point means you have an ordered pair, so you better be giving me a point and not just say at x equals 1 or whatever. The inflection point is an ordered pair, and that point in this case is 1, 3. Okay, that's now we have a couple more things to do. Number 4, x and y intercepts. Whoops. So for x, y intercept, what is my x-intercept? Again, this should be, oh, I should stick to the colors that I'm using here. It's very pink. It's probably because I don't personally like pink, but my 3-year-old loves herself some pink, so I'm getting kind of used to it, I guess. X-intercept is this point right here. Where does it cross the x-axis? This is a little tough to see, but we're at 1, 2, 3. Looks like about 3.5, so I'll put 3.5, comma 0. It's an intercept. That's the point where it crosses the x-axis, so please make sure you write it as an ordered pair. Same thing with the y-intercept. That one is 0, comma 2. I want to make sure I write that as an ordered pair. Number 5 is asking for undefined points. We don't have any undefined points, so there we'll just put none. This is a parabola, or excuse me, not a parabola. This is a polynomial function, some sort of cubic function. Polynomials are nice. They don't have any undefined points. They play well with others. And then any asymptotes, we don't have any asymptotes because polynomial functions, none. No undefined points. I should have said that instead of none. You want to make sure your reader knows what you're talking about, right? And your reader is me, and I give you points. So you should tell me, what does the none mean? It says no undefined points. What does this none mean? This means no asymptotes. Okay, so there's an example of how we describe a graph. Big things here. The big things really that we're going to focus on a bit is this increasing and decreasing, relative maximums, and concavity. The reason those are going to be important for us is because we're going to use calculus to learn how to do that. I have one more that I'd like to do, so let's clear this out. And let me show you one more. This, I think, was number 11 in your homework. Thought I'd do a couple homework problems just to help you kind of see what I'm expecting you to do here. Okay, so same thing here. I just want us to describe the graph using those 6 things again. I don't know why my handwriting's so bad today on here. Okay, so those 6 things again. Let's see. So number 1, intervals of increasing and decreasing. So let's look what happens here. I'm decreasing, decreasing, decreasing. These are just function values, remember. Decreasing, decreasing until about here, and then I start increasing, increasing, and it looks like I increase the rest of the way. So let's say decreasing first. We are decreasing from just 1 to 3, it looks like. And where are we increasing from? We are increasing from 3 to infinity. Good. And if we look at this, so the next one says relative minimum or maximum points. So I would say that this is a relative maximum point. Some books might not agree with that because the graph doesn't come from the other side and you usually need to find an interval around 1. But I think we could say that that is definitely a relative max. If I were a business person, I would probably want to be aware of that. And not only will it be a relative max, it'll be my actual maximum value. So what is my relative max? It's a max of 2, 3, 4, 5, 6. And where does it occur? This is how I want you to write these. It occurs at x equals 1. And we have a relative minimum also. I don't know why I've spelled that all out. You don't have to spell that all out. The minimum here is a little tough to see. It happens at 3, but it's not quite up at 1, is it? So I'm going to say like a relative min of maybe 0.9 or maybe, I don't know, maybe 0.8. I would give you credit for 0.8, 0.9, anything close to that. Where does this occur? It occurs when x is 3. Okay? Number 2, we do have a max. When it asks for number 2, it just says maximum or minimum value. What is my maximum value of the function? My maximum value is 6. What is my minimum value? This is an interesting one because it obtains an absolute max and min. My minimum value is, I guess we've decided, 0.8. Okay, so let's look at intervals of concavity. So my concavity here, let me see if this will work. So here I am going to be concave up from here until about here. Okay, do you see how I have a bowl that's basically, or a smile that's opening up, and then the other way I am going to be concave down. Now this is tougher to see, concave down, but it is concave down. If you look at the tangent lines here, we have a positive slope, but then notice my slopes are getting a little flatter, so that means that my slopes of my tangent lines are decreasing. That's what it means to be concave down. Concave up, the slope of my tangent lines are increasing. Look at the slopes here. The slopes of my tangent lines here, I would be negative, 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 negative until I'm not quite as negative till I get to 0. 0 is bigger than a negative number, and then I get positive. So you see how those slopes then are getting bigger. That's what it means to be concave up. Okay, so concavity, I would say we're concave up. Again, we're not going to include the endpoints. We're concave up from 1 to 1, 2, 3, 4. And we're concave down the rest of the time, from 4 to infinity. Okay, good. Inflection points. Well, we have an inflection point. We must have an inflection point because I changed concavity. What is the inflection point? Remember, it's a point, and it looks like it's 4 1/2. I will count off if you don't put it as a point, as an ordered pair. And that point is 4 1/2. Now I know this is a little weird because this is interval notation right here, and this is an actual ordered pair, so understand the difference. Remember, this interval notation says I'm concave up between 1 and 4. All right, X and Y intercepts. So my X-intercept, what is my X-intercept? We don't have one. Doesn't cross the X-axis. What is my Y-intercept? We don't have one. Does not cross the Y-axis. And that's okay, it doesn't have to. And then the last one, oh, undefined points. No undefined points on the domain, okay? So, I mean, I guess you could be like, well, Sarah, there aren't any points over here to the left of 1. Well, yeah, I understand what you mean, but what they say is no undefined points is, if I look at kind of the whole domain, the domain goes from 1 to infinity. From 1 to infinity, are there any points where I'm undefined? And then here we do have an asymptote. We have no vertical asymptote, but we do have, this one is interesting because we have a horizontal asymptote. Gotta be careful when you say that word. And what is my horizontal asymptote? It's a line. It's a horizontal line, so it's y equals 1, 2, 3, 4. So it'll be y equals 4, okay? It's that line right there. Y equals 4 is that horizontal line right there. I hope that makes sense. This is how I want you to write your solutions and your homework and on the next exam. So, so please practice this. You know, if you have any questions, you can send me questions before the homework is due and let me know what I can do to help you. All right, thanks for listening.